L70. This chart is just clearly showing you that at the point of 30% depreciation of lumens is the time to replace that luminaire or fixture. And the other half of the formula is at what hour or at what point does that luminaire meet that 70% or 30% depreciation point. You should know that most of MaxLite's products are L70 rated for 50,000 hours. So in other words, our fixtures, luminaires with an L70 50,000 hour rating will be at about 30% less of the initial lumens at the 50,000 hour point. The very basic that you should remember today from this webinar on LM79 and LM80 is LM80 is the LED information about that LED itself and is supplied by the LED manufacturer. And LM79 is third-party tested, and LM79 data is provided by the luminaire manufacturer or the light bulb manufacturer. That's the least I hope you can take out of your understanding of those definitions. Now let's talk a little bit about the actual performance of LED luminaires. We get a lot of questions here at the MaxLite training department, and it's often about, well, I'm looking at your cut sheet and I see that you have an efficacy or lumens per watt of 62 or 58. And I read an article recently where LEDs are now 100 lumens per watt or 120 lumens per watt. Can you put those LEDs in this luminaire for me? And this chart that we're looking at together now is really to demonstrate how the raw LED lumens per watt translate into the fixture luminaire light bulb lumens per watt. So the article that you may have read recently is that, you know, XYZ LED manufacturer, maybe Cree or LumaLED, Sylvania, somebody has come out with a new LED that's 130 lumens per watt. I've actually read articles recently up to 150 lumens per watt. Let's understand that that's in the laboratory. If they're not commercially available, I don't have access to those. Those LEDs that you're reading about today at 130, 150 lumens per watt will be available to the luminaire manufacturer probably in 12 to 18 months. And at that time you'll be reading articles of much higher lumens per watt in the lab. Commercially available today is just over about 100 lumens per watt. Now I've got that LED, that raw LED in my hand, and I'm going to apply it to my luminaire or light bulb. I have to design into that completed fixture a thermo protection. So I'm going to down rate my LED by about 10% to ensure that when it heats up in that luminaire that it doesn't overheat. I'm also going to move some of that light optically so that it's exactly what you expect in its application. For instance, if this is for an office type environment for a 2x4 lay-in, I'm going to have a different optics than if this is a light bulb designed to go into an MR16 pendant. Those optics, as we move light around, as you know, there's a luminaire light loss factor, and that can be as much as 15%. Then I have to have a driver. A driver to an LED has similar relationship as does a ballast to a fluorescent bulb. And again, I lose a little bit of efficiency there through the driver itself and through controls and the like. And at the end, when I buy that 100 lumen per watt LED, my fixture might have an efficacy of about 65 lumens per watt. I think that this is articulated in this manner to demonstrate to you that there are design efficiencies that you must consider, and somebody who's selling an LED luminaire or light bulb touting 100 lumens per watt is misleading. They're just saying that they're using a particular LED. It's not speaking to the efficiency of that particular fixture. Any claims that are too good to be true, in my experience in lighting, are always not true. One of the most important features of the LM80 data that we get from the LED manufacturer for us to consider when we're designing our luminaires and light bulbs is the junction temperature or the maximum temperature rating at specific points of that LED. We back design our luminaires and light bulbs from that point so that we never exceed that junction point, that junction temperature. This junction temperature data tells us the lumens that you're going to have today, tomorrow, 5 years down the road, 8 years down the road, and beyond if we manage it properly. If it's mismanaged, every published data about that LED and likely the luminaire that they'd be selling would not last long. So thermal junction temperature, which is supplied in the LM80 data, is really the key to the success and longevity of that light bulb. To manage that junction temperature, when we're building a luminaire light bulb, we do everything to ensure that it never reaches its maximum, and well below it if at all possible. That's why you see these light bulbs that have heavy aluminum finned housings. There's a few in the market out there that have plastic housings. If you look through the lens in the front, you'll see a green PC board with 5mm LEDs mounted to it. Run from those. Of course, they have a great price. You've bought a very substandard product, and more important than just failing your customer or end user, it really puts a negative taste for LEDs in general. So let's be careful that when we're looking at these products, they're at least defined as substandard or not quality made light bulbs. And very similarly, I have seen light outputs in fixtures and luminaires that were quite impressive, but when we studied it closely, the things were not thermally protected. They were well beyond the junction temperatures recommended, and you can watch the lumens depreciate like an hour hand on a clock. They slowly go down. I have seen luminaires that cost $400+ in the market, light bulbs that cost $60, $80 in the market, that had 50% depreciation at 1,000 hours when they were installed in the likely application that these designs were for. So be very careful. Application efficiency, LEDs, unlike incandescent, are, well, they're more like a laser in that they're very monodirectional. The light is designed to go in a very specific direction, so it's probably not likely that you would see a incandescent-shaped LED that put light out 360 degrees like an incandescent bulb does in all directions. With current technology today, it would be very efficient at putting a bright spot on the ceiling above a table lamp with an LED light bulb, but it would have a hard time lighting up evenly the full shade and certainly the area around it. So it's important to know that LEDs can have limitations as far as their application, but fortunately, most products on the market today are utilizing the monodirectional nature of LEDs, and that's why there are great applications out there. And MaxLite and other leaders in LED technology are focusing on those applications where LED strengths can be added and bring those return on investment times down, lower costs for your applications, and so on. The better the efficiency, the lower the power consumption, but also the higher the lumen.